Hi, everyone. Thanks for inviting me. I'm really happy to be here. So thank you all for joining this session on Spring Cloud Gateway, Resilience, Security, and Observability. As you heard, I'm Thomas. I work as a software architect at Systematic in Denmark. I wrote a book about some of the technologies that I like working with, Java, Spring, Kubernetes, and in general, cloud-native technologies. I'm also a big supporter of open source technologies whenever I can. I like contributing to different open source projects, both in the Java ecosystem and in the cloud-native space. So today, we're going to start by talking about the API gateway pattern. So before diving into technologies and Spring Cloud Gateway, let's look at what is this pattern, why we need it, and what are those scenarios where we can really take advantage of its benefits. So the first scenario that we might come to mind is when we have a distributed system where different clients need different APIs. So one way of solving this problem is having each of the systems or the applications in the backend exposing different APIs, or we could put a gateway in between the clients and the backend services that can provide a more curated and customized APIs based on the different needs that different clients might have. And other scenarios where we might consider introducing a gateway in our architecture is when we start by having a single monolithic application, and then we want to start extracting some functionality as an independent service. So think about microservices, for example, using the strangler pattern. If we put a gateway in front of that, then we can start doing this operation in the backend without affecting the client. So while still ensuring a consistent and coherent APIs to all our clients and users of our applications. When we start working with multiple applications, so with a distributed system, like in a microservices architecture, then we have the need to still ensure a nice experience for our clients. We don't want the clients to keep track of all the different services that we have in the backend. So having a gateway providing a unified interface can really help. And finally, since we are talking about introducing this new component into our system, into our architecture, the gateway will be sitting as the entry point to our system. So we might think of taking advantage of it and handles different cross-cutting concerns that we usually have in distributed systems, like, for example, observability, resilience, and security that we're gonna talk about today. The example that we're gonna work through will be a fictitious system for a public library. We have an edge service that is the one implementing the API gateway plus handling all these cross-cutting concerns. And then in the backend downstream, we have different services that deal with different functionalities of the library system. In particular, we're gonna focus on book service as an example, but the same will apply to any other service. So let's start by looking at book service. I have already built that. It's a very simple Spring Boot application. You can see here, I have a main method to initialize the application. Then I have defined a record named book that is the domain model for our example. And then we have a book controller. In this class, we expose a books endpoint, returning a list of books. Very simple. There's also a log message, will be important later. And that is it. That is the book service application. We can even give it a try and see how it works. I'll open my terminal and send a GET request. So the application is exposed through port 9001. And we can see the result. So list of books. Now, what we want to do to begin with is introducing this edge service component that implements the API gateway pattern. So to initialize the project, I can go to start.spring.io, the Spring initializer up. From here, I initialize a new Gradle project. I'm going to use Java and the latest Spring Boot version 3.0. And the only dependency I need here is the Spring Cloud Gateway dependency. That's for starters. So once we have this, we can start configuring and implementing the gateway and those cross-cutting concerns. So we're gonna start small. So I have already imported the application in my editor. You can see it's another Spring Boot application. We have a main method initializing the app. And at this point, I can start configuring the gateway in two different ways. I could use the DSL provided by Spring Cloud Gateway, either in Java or Kotlin, or I can use configuration properties from the YAML file, the application YAML file. Now, it would be much easier for me to demonstrate it using Java or Kotlin, but in a real-world scenario, we probably are going to end up using the YAML properties, because by doing that, we externalize the configuration, and then we can change it and customize it depending on the environment where we're going to deploy the application. So I have an application property file here. The name of the application is Edge Service, and now I can start configuring the gateway. Now, the basic functionality of a gateway is to route requests from a client to a service downstream. So we're going to start by defining a route so that we can access the book service through the gateway. So in a new route section, each route has an ID, a unique identifier. Let's call it book route. Then I have to specify where I want to route the request. In this case, it's on localhost 9001. And then I have to tell the gateway when, what is the condition that needs to match in order to forward a request to book service. And I can specify that via a predicate. Now, Spring Cloud Gateway provides out of the box a wide variety of predicates. In this case, I want to match against the request path. So every time a request starts with /books, I want the gateway to forward the request downstream to book service. And that's it. So this is actually quite boring. It's basically a proxy. So let's start and make it more interesting. So to begin with, we can think of manipulating the request before sending it downstream. I can do that with filters. Now, filters are what makes Spring Cloud Gateway so powerful. We have a lot of different filters that come with the library out of the box. We can even implement our own. So I'm going to start by having a filter to add a request header. And we might think to have a multi-tenant application, so perhaps a tenant header with tenant name Acme. And I can even manipulate the response that I get from book service before sending it back to the client. So I can say add response header. And maybe since we're talking about books, we can have a custom header with the type of the genre of the book, fantasy books. All right. Now that's enough. We have defined the route, the predicate that will trigger the route, and some filters. We have a filter that will manipulate the request before sending it to book service. And once book service replies, we also have a filter to manipulate the response. So let's have a look at how it works. So earlier, I called the /books endpoint on port 9001. That's where book service is running. But now I want to go through the gateway. So I'm going to go through port 9000. That's my edge service. So you can see that the result is exactly the same, except that now the request went through the gateway. And you can verify that by looking at the headers in the response, because we have the custom header added back. We can even have a further look at what is going on under the hood. I have already configured my system with an observability setup based on Grafana. So I can go and check the logs for my book service application. I'm going to use Loki, which is the logging solution within the Grafana stack to manage logs. And if we go down here, we can see the log message returning list of books in the catalog that we have in the book service application. But I also have a trace ID here. It means that I'm tracing requests across different applications. That's what is called distributed tracing. So if I click now on this link, a Tempo window opens up. Tempo is the distributed tracing solution in Grafana. And I can see what is happening under the hood. The request comes from Edge service first, and then it's forwarded down to book service. So I can even see different attributes and time about these two parts of my request handling, which is really nice. I have configured also metrics scraping via Prometheus. So for example, I can check the JVM properties of my application, how the memory looks like, CPU consumption, and so on and so forth. All right, so let's recap what we have seen so far. We have started implementing our gateway, our edge service, by defining some routing configuration. This is the main architecture of Spring Cloud Gateway. We can see that a client sends a request. A predicate is used to match a request to a specific downstream service. And then we can apply some filters, both to the request before sending it downstream, but also to the response before sending it back to the client. Then we also started looking at the observability part of our system. Now, you might think that it's a bit strange to talk right away about observability, even if our application and our system is not ready. But actually, my recommendation is to push observability left as much as possible, because it's super critical to have observable applications in production. But if we have the same setup also during development, then we get many more possibilities for developing our solution faster, to debug, to test that everything is working correctly across different applications. In particular, I used the Grafana open source observability stack. So I mentioned Tempo for traces, Loki for logs, and Prometheus for metrics. And then from the Spring point of view, we have a couple of libraries that we can add to our applications to get a lot of this set up out of the box. The first library I want to mention is Spring Boot Actuator. And it's really powerful because it provides out of the box a lot of different endpoints for monitor and manage the application. So it exposes metrics in different formats, including Prometheus, which is what I'm using here. It exposes health information, like liveness and readiness probes that are used on Kubernetes. And plus a lot of different informations depending on what your application is doing. So if you're doing schema migration with Flyway, for example, then you can monitor the Flyway migration status as well, or take a heap dump if you're looking into a performance issue. Maybe you're trying to find a memory leak that is useful. And then we have a project. So until Spring Boot 2.7, we would use Spring Cloud Sleuth to enable distributed tracing across our Spring Boot applications. But starting from Spring Boot 3 and Spring Framework 6, that will be released later this month, will be GA later this month, this support has been added via a micrometer tracing project that exposes a facade, and then you can choose your implementation of choice for the tracing. For example, in my case, I'm using OpenTelemetry, but if you want to, you can use OpenZipkin. All right. So we have this basic setup now. We have a gateway in place. We have some routing definition. Let's start looking at how can we make our system more resilient. So we're going to look at a few different patterns to improve the resilience of the gateway and the interactions both with the clients and the services downstream. The first pattern I want to mention is the retry pattern. Now, picture this scenario. Book service might be momentarily unavailable. So if we call the gateway to get the list of books, then book service will probably reply with a 503 error saying service unavailable at the moment. So what we can think of is retrying the request a few times before giving up and returning an error to the user. Now, this pattern is really useful if we are talking about idempotent requests. So GET requests are usually idempotent. What I mean by that is we don't want to retry requests that change the state. So I don't want to retry, I want to only retry requests that if I run them multiple times, the result is always the same. So in general, that would be GET request. It could be also POST request, but we have to be careful. For example, a POST request to update my profile picture on my Twitter account, I could think of trying that multiple times. The result will be the same. But in general, it's not safe to use this pattern for any request. So we have to be careful when we use this. And it works in this way. If we look at our example of Edge service and book service, we send an HTTP request to the book service. We receive a 503 error, service unavailable. We wait a bit and try again. Once again, an error. Then we wait a little bit longer. So it's really important that we don't keep retrying the request one after the other. But every retry attempt, we wait a longer time between each attempt. That's called a backoff strategy. And it's important because we want to give book service a chance to recover. If we keep bumping it with all these requests, then we probably make the situation worse, and we even risk to attack our own service with a denial of service attack. Ultimately, if the request after a certain number of attempts succeeds, we return the result to the user, to the client. Otherwise, we give up, and then we can handle it gracefully. Perhaps not just an error message, but maybe we can return a cached result from a previous request, or some more user-friendly message, just to help the user or the client through this error situation. So let's have a look at how we can implement this in a Spring Cloud Gateway. Let me move to this different branch. All right. So I mentioned earlier that filters are basically what make the Spring Cloud Gateway so powerful. And all these resilience patterns that we're gonna see are actually implemented via filters in the gateway. For the retry filter, I'm gonna use a more extended syntax here compared to the previous two, because I want to specify some additional arguments. So first of all, I want to specify the number of retries, for example, 3. So if the request fails, I retry up to 3 times. Then I want to make sure that I only retry get requests that I know are idempotent. And then I want to configure the backoff strategy. So as I said, I don't want to keep retrying at a fixed rate, but I want to have increasing delays between each retry attempt. So I can define a minimum backoff, let's say 50 milliseconds, and the max backoff of 500 milliseconds, something like that. All right, yes. Then I'll rerun the application, and we're gonna try that out. All right. Yes. Speaking about resilience, so I have some network issue on my local environment, so just a sec. Yes. So while I make that work, one last thing is that the retry request, you can also specify when should be triggered. So you can specify the exceptions for which you want to retry. I'm gonna rely on the default. Let's give it another try. I have the whole observability setup running through Docker, so all my applications are running as Docker container now. All right, we got it. So if I go back here and send a new request, nothing changes because, of course, book service is not, is healthy, is not having any problem. But if I stop book service like this, and I try the request again, I can see that it takes a bit longer because it tried a few times to send the request, and then it ultimately fails. And I can even see in the logs that in the traces, I can see that Edge service is trying to send the request. Book service, of course, is down, it's not receiving anything. I can even check the traces here for Edge service and get request to compare the time, the execution time, when the service is available and when it's not available. All right. That was the retry pattern. Next, I want to talk about the request rate limiter. The retry pattern was applied between edge service and book service, but in general, it's a pattern you can use across your entire system every time you have an integration point between two different applications. Request rate limiter instead is used to make more resilient the connection between clients and edge service. Since edge service is the entry point of our system, what we can think of is to limit the request rate, because perhaps we know that our system has a certain limit of requests that can be processed every second. So we want to prevent our system to go down, to enter an error state. And for that reason, we want to limit how many requests we receive. So that's the resilience point of view, also to protect against denial of service attacks. But there's also a more like business point of view, because having a request rate limiter means that if we have a public API that we sell at an enterprise level to different customers, we can think of having different subscriptions level for our API consumption. We can have a basic level, a premium level, and a gold level. And then we can have different rate limiting depending on the subscription that each customer purchased. I really recommend about request rate limiters to read this interesting article that is linked here by the engineers at Stripe. They explain in particular how to implement a request rate limiter using the token bucket algorithm. How it works is that each user is assigned a bucket with some tokens in it. For every request, I have to pay one token. So when the bucket is empty, I can't send any new request because I don't have any tokens. The bucket is replenished periodically, so I have to wait to get more tokens in order to send more requests. And this is the exact same pattern that is implemented out of the box by Spring Cloud Gateway. We can have a look. And once again, we have a filter, but because it's something that probably we want to apply in general to our edge service and not to a specific route, I can define it as a default filter rather than being applied only to a specific route. So I have a section here for the default filters like that, and I can define the configuration for the request rate limiter config. Yes. Now, if you think about it, the request rate limiter approach relies on the fact that we keep track of how many requests each user is sending to our application. That means that we have to keep the state, and that means that our application is stateful. And that's a problem for us, because if we want to scale the application, so edge service has the risk of becoming a single point of failure. So at least we want to have multiple instances of it running, so that if one goes down, then our service is still available to our clients and customers. But if we have the state saved inside the application, we're gonna have a problem. Of course, Spring Cloud Gateway knows about the problem and actually provides a solution. This request rate limiter by default relies on storing the state in a Redis data store. So what I'm gonna do now is moving to the next branch, and I can show you how to change your project. So far, we've been working just with the gateway dependency, but now since the request rate limiter filter relies on Redis, I also need to add a dependency on Spring Data Reactive Redis. Gateway is a reactive application, so that's why I'm choosing the reactive version of Spring Data Redis. All right. So at this point, no, yes. So we have the configuration for the request rate limiter using Redis. In this case, we have a bucket with 20 tokens. Each token is requested for each request. So one token, one request. And then every second, we put 10 tokens back in the token, in the bucket. So let's have a look at how it works. So since we have 20 tokens in a bucket, it means that that is our burst capacity. So I can't send more than 20 requests at a time. And since the replenish rate is 10, I can't send 20 requests one after the other, because the replenish rate is half of it. All right, so we go here, we send the request. Once again, nothing changes in the response body, but you can see these additional headers in the request that tell you about the rate limiting that is happening under the hood. In particular, we can see that we have 19 remaining requests. These headers are added by default. For security reasons, you might not want to return this kind of information, but you can disable it via configuration problems. So that's not a problem. And one more thing, let's see, I want to try to get rate limited. Let's see, so if we send 30, let's do 50 requests concurrently. This is a tool called Apache Benchmark. I want to send 50 requests, all in parallel. Let's see how many of them will succeed. All right, so we have 50 completed requests, but 30 of them failed. And that makes sense because in less than a second, I sent 50 requests, but the burst capacity, the bucket contained only 20 tokens. So 20 requests went through, the other 30 have been rejected as expected. All right. Now, the next pattern is quite interesting. It's called circuit breaker. And this comes from electrical systems. Probably in your apartment or in your house, you have a circuit breaker that prevents any kind of damage to one of your maybe electric furniture in your apartment, some device, your TV, something that can fail from propagating to the rest of your circuit in your apartment or in your house. That's the same approach that we want to use in a system. The goal is, if one component fails, we don't want the failure to propagate to the rest of the system. We want to trap it. We want to block it and isolate it so that worst case scenario, we have a graceful degradation of the functionality, but we don't have a total breakdown. That's the goal of a circuit breaker. And we have 3 states. The default state is closed. Once the breaker is closed, it means that, for example, from edge service, I can call book service. But if the failure rate from edge service to book service goes above a threshold, then the breaker trips and the circuit becomes open. That means that I cannot send requests from edge service to book service anymore. It will stay in the open state for a while. After some time, then it goes to a half open state. That's kind of an exploratory state. It will allow only a few requests just to see if book service is up and running again, if it recovered from the failure. If it did, then the circuit becomes closed again, otherwise open once again, and we have to do this whole loop again. Now, an example can clarify this. So let me move to the code. We have to do one thing first because we need to update our dependencies. Spring Cloud Gateway provides a filter to implement circuit breakers, and that implementation is based on the Spring Cloud Circuit Breaker project. The Spring Cloud Circuit Breaker project can have multiple implementations. I choose to use the one backed by Resilience4j, which is a very powerful Java library to implement different kind of resilience patterns. In this case, we're going to use it for the circuit breaker. So once we have done that, I can configure the circuit breaker here. It's another filter, circuit breaker. And the arguments, so we have the name of the circuit breaker, for example, book service, or let's use this case, book service. And what we can configure for this circuit breaker is that whenever the circuit is open, we can provide some fallback behavior so that we don't return just an error to our clients. That's the point of having this graceful degradation. So I can define a failbook URI, fallback URI, book fallback. And I can implement this endpoint inside my edge service application. So in a real world scenario, as I said earlier, I could think of, for example, returning a cached result or any other way to help the user and try to minimize as much as possible the disruption of the service, because we still want to provide our entire system as a service, but then try to minimize how the user is impacted. Then we have to configure the circuit breaker. That's a lot of YAML. So I'm gonna get it from here. So we have, there it is, yes. So we have resilience for J configuration that can happen via YAML, as I'm doing here, or via the Java DSL. I have a circuit breaker instance called book service. It's the same one that I want to apply to the book route. And then I have a bunch of configuration here. So what does this mean? The first option is the sliding window size. It means that the circuit breaker will consider the last 10 requests that we send to book service. If at least 50% of them fail, then the circuit trips and become open, and it waits in the open state for 10 seconds. After 10 seconds, it goes to a half open state where only 5 requests are permitted. And once again, if 50% or more of those requests fail, the circuit becomes open again, or it goes back to being closed. So let's look at an example, because you can clarify things a lot. We have the observability setup that we can use to visualize the circuit breakers and how this state transitions depending on the state of the service. So let's make sure that I have all the services up and running. There it is. And then I'm gonna do, so we have here some dashboards. So I have a dashboard for the circuit breakers. There it is. So we have the edge service application. We have one circuit breaker, in this case, called book service, and right now is closed. So let's try to make it fail. Maybe we can do it up here. All right, so now if I send a request, the circuit will still be closed because everything is working correctly. So in order to visualize what happens when something goes wrong, I'm gonna stop again book service like this. All right, and now I send, let's use Apache benchmark again. I'm gonna send 10 requests, since the circuit breaker will only consider the last 10 requests. Like that. So all of them will fail because book service is not up and running. So what I expect right now from the circuit breaker is to trip and become open. So let's give Prometheus a couple of seconds to update the status here. And we can see that the circuit now is open. Now, this kind of visualization is really, really important. So if you work with circuit breakers, look into monitoring and alerting before going to production. Because, for example, in this case, since the circuit breaker is open, I would really like to get an alert, because it means that something is wrong in the system. So I want to have a look at it and fix it as soon as possible to avoid even more disruption for our customers and end users. So in this state will remain for 10 seconds. That's how we configure the system. After that, any subsequent request will be considered when the circuit is in a half open state. As I said, that is an exploratory state. It's just to verify if book service is now up and running again, or if it's still failing. So first, I want to start book service again, like that. Let's make sure that is up correctly. Yes. Now I send only one request just to trigger the half open state, like that. Now that Prometheus refreshes the dashboards, we can see that the circuit becomes half open. And that was one request. we still have 4 requests to go before the circuit breaker decides whether to become closed or open. So you can see now it's half open. If I send 4 more requests, they will all succeed. So we are never going above the 50% failure threshold. So the circuit breaker will become closed again. And drum rolls, while Prometheus refreshes, I can even trigger that, yes. And now it's closed again. So everything is working as it should. Nice. So you might have noticed that in the configuration, I didn't just configure the circuit breaker, but I also configured the time limiter. Now, time limiters and timeouts are the same thing. It's an important pattern because we really want to limit the amount of time we wait for a request to be completed. So in the case of the circuit breaker, or in the case of the retries, we don't want to wait too much time before making a decision whether the request was successful or a failure. So we can use a time limiter, and even in this case, define some fallbacks. So in the case of book service, for example, we can have book service replying correctly. That's no problem. But if the time limiter is exceeded, we can do 2 things. One is just throwing an exception, for example, a timeout exception back to the client, or we can return a fallback behavior. So that when the timeout expires, we have this nicer way of dealing with the error compared to just throwing an exception and have the customer or the client deal with it. And in the example, I have a time limiter here for the book service circuit breaker, 3 seconds timeout. That's a long time. Probably I would lower it in a production environment. And then we have a fallback endpoint that I mentioned earlier. There it is, books fallback. In this case, I'm just returning an empty list of books. But in a production real-world application, again, think of a way of making this a graceful degradation of functionality. For example, caching the result and returning a cached result. Yes. Now, so far we've been talking about resilience for the gateway and in general for our distributed system. But once we have the gateway in place, we can even use it to deal with some security concerns. For example, user authentication. This is the entry point to our system. So it makes sense to use it also to authenticate the user before routing requests downstream to any of the other service. And one way of doing that is using the standards OpenID Connect and OAuth 2. So if we consider the authentication part first, we can use OpenID Connect so that Edge service initiates the authentication flow, but then the actual authentication step is delegated to an authorization service. So that could be Keycloak, could be Google, Twitter, GitHub, it could be the brand new Spring authorization server. And the nice thing is that we isolate the concerns regarding how we want to authenticate the user into one single service, because Edge service will speak the OpenID Connect language and receive an ID token with all the information about the user identity. But then we don't have to change Edge service if we want to provide different authentication mechanisms. So Edge service will not change if we want to change how Keycloak, for example, authenticates user. It could be username and password, two-factor authentication. It could be a social login. It could be a login via an Active Directory that perhaps the employees of the public library already have. So it can be anything. It's a quite flexible approach. And that is for authentication. However, we are in a distributed system. So once the authentication step is done, we have to propagate somehow this security context downstream. So how can we send that information down to book service? And that's what we use OAuth 2 for. In particular, we have an access token that Edge service will receive from Keycloak in our example, and then forward that access token every time it sends a request to book service. Now, all of this seems a lot of work to implement user authentication, but actually is provided out of the box by Spring Security because it's all based on standard OpenID Connect and OAuth 2. Furthermore, since we have Spring Cloud Gateway, we get this token relay pattern also implemented out of the box because Edge service will keep a mapping between the user session in the browser and the access token, and automatically will relay the token to all the services downstream, for example, book service. So let's have a look at how that works. I'll switch branch again. All right. So first of all, if we go back to the Spring Initializer, I have to add a new dependency on OAuth 2 client. This includes Spring Security and all the necessary libraries to make the flow work as an OAuth 2 client. The OAuth 2 client is the component that initiates the authentication flow when we use OpenID Connect. So that will be our Edge service. Book service instead will act as the resource server, which is the one that contains the data that we want to protect and for which we need to provide authentication and authorization in order to have access to those protected resources. All right. So we go back here, and the application property file, I have configured the Spring Security integration with Keycloak. I have a local instance of Keycloak running on my machine. And what I have to define here is a way of authenticating with Keycloak, and I'm using the super secure and secret Polar Keycloak secret here. And then we have the scope OpenID. This is an important setting because this is what triggers the OpenID Connect authentication flow on top of OAuth 2. OAuth 2 is the framework. OpenID Connect is an extension to OAuth 2 to add authentication. That's one thing. So now all the endpoints in Edge service will require authentication, but we are not done yet. We have to propagate the access token down to any service that we want to forward the request to. So we need two additional filters. One filter is the token relay filter. That is the one that takes the access token and include it in every request header sent downstream. So we don't have to do it ourselves. The other one is to save the user session and keep that mapping between user session and token. This is a very important part of the implementation. And once again, so earlier we talked about making the application stateful with the request rate limiter, and we externalize the state to Redis. We can do the same with the session. And for that, I can use the Spring Session project. So that is another dependency that I need to add here. With Spring Session, I get automatically the session externalized to Redis because I have a Redis dependency right here. So I don't need additional configuration. All right, that is it for Edge service. I just want to show you what happens in book service because we had to slightly change it so that book service can call Keycloak at this URL and get the public key in order to verify the signature of the access token, which is sent as a JSON Web Token, a standard format. All right, so let's start up the new version of the applications and make sure that they are initialized correctly. Yes. And yes. So now I'm not going to use the terminal because we need to log in. So we have some interaction happening in the browser. So let's go to localhost 9000/books. That's the usual endpoint that we've been working with so far. And if I do that, I can, I'm redirected to Keycloak now because I'm not logged in yet. So I can log in here. Now I'm using a username password strategy. This could be really anything. Keycloak provides a lot of different ways to authenticate users. You can configure that, and the change will not affect Edge service at all, which is one of the cool things about OpenID Connect. So I sign in, and I'm redirected back to my book service through the Edge service, and there is it. I get the result back. I can even go and check the logs and the traces. Let me close this one and refresh the logs. So we have the list of books. We can use the trace ID in order to correlate the information with the traces. And now, since we have introduced security, we even get additional information about how Spring Security is working under the hood. So if you extend here, we get the request received by book service. And then we have information about the checks that Spring Security does in order to verify that the request is really authenticated and authorized. So this also helps in understanding what is happening through your distributed system. One last thing I want to show you is that I mentioned earlier Spring Boot actuator that provides a lot of different endpoints dynamically depending on what dependency you have in your class path. And in the case of Edge Service, because I have Spring Cloud Gateway, I get additional information about that. So if I go to /actuator, I can see actuator/gateway. Oh yeah. Let me do it differently. We have the information from the gateway exposed, and I can visualize them in a dashboard. So you can see this is for a Spring Cloud Gateway dashboard. So I'm getting specific information that Spring Cloud Gateway generates. I have the gateway service, edge service. I can specify what route I want to monitor. So I can see that I have 1 total request served and 30 unsuccessful requests served. So this 30, funnily enough, this comes from the earlier experiment that I did when I wanted to trigger the request rate limiter. If you remember, I sent 50 requests, 20 of them were successful and 30 were unsuccessful. So there it is, we have the number. And then we have different informations about all the API calls. So you can monitor also how the rate limiting works and how your API is doing. Yes. All right. So we talked about, in general, the API gateway pattern and basic functionality. In particular, Spring Cloud Gateway offers these really powerful filters that you can use out of the box, or you can implement your own. We talked about resilience and look at different resilience patterns. Now, I mentioned them in the context of a gateway, but I want to highlight that those patterns are useful for any application in your system. So every time you have an integration point between two applications, you can think in terms of how about the timeout? How long are we waiting for a request? Do we want a retry? Do we need a circuit breaker? Do we need some rate limiter? So in that regard, I really recommend considering these patterns also in the context of any of these downstream applications. So you can have a look at Resilience for J, the library that I use for the circuit breaker that offers a lot of these other patterns implemented and configurable in a very nice way, either via configuration properties or via Java. If you want to explore some of the different features offered by the Spring ecosystem, which is huge, I maintain a GitHub repository with a collection of curated resources. There are books, courses, podcasts, events. So if you're interested in learning more about Spring, you can check out this repository. I'm going to share with you these slides, of course. The project, all the code is on GitHub, so you can give it a try yourself. And that was it from me. Thank you very much for joining this session. If you have any questions, please ask away. We also have 3 copies of the book to give away. So yeah, thank you. Thank you very much.
Thank you very much, Thomas. Yes, we have some questions on the chat. I will give it to you now.
Yes.
First one, is Spring Cloud Gateway still needed in Kubernetes context with Kubernetes services, Istio, traffic?
Yeah, that's a really great question that I get a lot. So the way I like to see this context, like Spring Cloud Gateway and Kubernetes, is who will be responsible to implement certain features. So if the developer is responsible or has the knowledge of how to define the resilience patterns or the security configuration, then Spring Cloud Gateway is meant to be used by developers directly. So I would go with Spring Cloud Gateway. If certain features are will not be responsibility of developers, think about I don't know, routing at the platform level or mutual authentication MTLS, then I would go with a service mesh and an ingress controller in Kubernetes. So actually, what happens in reality is that we use both. So in the architecture, we have the Kubernetes ingress at the entry point of our system, and that is maintained by the platform team, and making sure that we have all the security and compliance in place. And then we have the Spring Cloud Gateway component after the Kubernetes ingress that is instead maintained by developers and being maintained and configured and customized by developers. So I don't think that it's either or, but actually they are used together. And the way of figuring out where to put certain features, my recommendation is to think about who will be responsible for it. Because if I'm using, let's say, Istio as a service mesh to implement some of these circuit breakers, for example, are you expecting the developer to know about Istio, to know how to configure Istio? Probably not. So that is where, that is how you can decide when to use Spring Cloud Gateway, when to use a service mesh, and when to use an ingress controller in Kubernetes. I hope that answers your question.
We have 3 more questions. So first, can you have more than one circuit breaker?
Absolutely, yes. In this example, I had only one route to book service, but let's say that I have, so if we go back to this diagram, if I have also the other 2 services like inventory service and order service, then I can have a circuit breaker for each integration point. So one for inventory, one for book, one for order. So you can have multiple ones. Each circuit breaker covers one specific interaction between 2 components. Yeah.
Is it a good practice to use a key clock behind a gateway?
Yeah, so perhaps that's related to what I was talking about earlier. So I think they are used together. Like you can deploy Spring Cloud Gateway on Kubernetes. There's also a Kubernetes native enterprise implementation of Spring Cloud Gateway that runs on Kubernetes provided by VMware Tanzu. So definitely they can work together, but you don't need Kubernetes to use Spring Cloud Gateway. So you can use it also in other environments. Yeah.
And the last question here is, are there any liabilities in integration a gateway with a find client? Yeah.
So I think that would be a different way of implementing such a pattern. Like the gateway is more generic for a routing request. The find client or one of the new declarative client functionality that you can find in the new Spring Boot 3 that is coming up, that provides a more powerful and extended way of using find clients. I would use that. For example, let's say that the book service has to call the inventory service. Then in that interaction there, I would use perhaps a find client, but then I would keep the gateway more abstract or more generic, so that I don't have to specify like a client for each of the backend services. So I hope that answers the question.